shapes of molecules. So quite a bit, but I've been able to summarize it, all the key information, I guess, all on one piece of paper, which is good. So BeCl2, BeCl, 180 degrees, 2 electron pairs, no lone pair, no lone pairs, linear shape. BF3, BFFF, 3 electron pairs, no lone pairs, trigonal planar. Yeah. NH4 plus, it should be 120 degrees bond angle. Yeah, it should be that. I don't know why I didn't include that. NH4 plus, nitrogen, positive charge, arrow, here, hydrogen, bond angle 109.5 degrees, wedge here, hydrogen, and then bond sticking out to this hydrogen. 4 electron pairs, no lone pairs, therefore it's tetrahedral. I'm going to come into this part later. Let's just finish off with the shapes of molecules. PF3, PF, 170 degrees bond angle, F, wedge, dash F, 1 lone pair of electrons. 4 electron pairs, 1 lone pair, trigonal pyramidal. H2O, oxygen, 2 lone pairs of electrons, bond angle 104.5 degrees, hydrogen, hydrogen. 4 electron pairs, 2 lone pairs, it's called bent. PCl5, PCl, and the wedge here with Cl, and bond sticking out Cl, 120 degrees bond angle and 90 degrees bond angle, and it's just like this triangle. You can go like that. 5 electron pairs, no lone pairs, trigonal bipyramidal. SF4, SFF, wedge sticking out to this F, bond sticking out to this F. Bond angle 102 degrees, 87 degrees bond angle here, 102 degrees bond angle here. 1 lone pair of electrons, 5 electron pairs, 1 lone pair, seesaw shape. ClF3, 5 electron pairs, 2 lone pairs. ClFFF, 88 degrees, 2 lone pairs of electrons, 5 electron pairs, 2 lone pairs. T-shaped. SF6, SFF, bond sticking out F here, bond sticking out F here. Wedge here F, wedge here F, 90 degrees, 90 degrees, 6 electron pairs, no lone pairs, octahedral. XeF4, Xe, bond sticking out here, F, bond sticking out here, F, wedge here, F, F, 2 lone pairs, 6 electron pairs, 2 lone pairs, square planar, and a bond angle 90 degrees. Now, how to use a number of electron pairs to predict what's the shape of the molecule. So we need to firstly identify the central atom, work out the number of electrons in outer shell of the central atom, add to 1 for every atom the central atom is bonded to, divide by 2 to find the number of electron pairs on the central atom, then compare the number of electron pairs to the number of bonds to find out the number of lone pairs. Some cases you'll have no lone pairs, some cases you might have 2. To find the number of lone pairs and number of bonding pairs on central atom. If we're dealing with an ion, however, after step 3, so work out central atom, work out number of electrons in the outer shell of central atom, add 1 to every atom is bonded to. If we work with dealing with ion after step 3, we add 1 if it's a minus charge on the ion, and we subtract 1 if it's a positive charge. Like for example here, NH4 plus. After step 3, we subtract 1. Because in the exam, they're going to give you maybe a molecule and they'll say predict the shape, and you're going to have to use this method in order to work out the shape. If it's not any of these and you're unfamiliar with the molecule, you're going to have to use that method, and you're going to be really confident with it and do it really quickly. So definitely need to learn this method. Work out central atom, work out number of electrons in the outer shell of central atom, add to 1 for every atom central atom is bonded to, divide by 2 to find number of electron pairs on central atom, compare the number of electron pairs to number of bonds to find the number of lone pairs and bonding pairs, number of bonding pairs on central atom. And if it's ion, add 1. If it's minus charge, subtract 1. If it's plus charge after step 3.